Hi, welcome to the channel. Here I post challenging math problem videos. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. So today we will do problem based on definite integral. So the problem says integration of 0 to pi x log of sine x. So what we can do is we apply the King's property. So we can write 0 to pi. This is pi minus x ln sine pi minus x dx. Okay, so if we bifurcate this two integral, so this is ln of sine x minus x ln sine x, and integration 0 to pi 0 to pi. Okay, so this is I. So this is also I. So this is 2I, taking this I to the right hand side, sorry, left hand side. So this is pi and 0 to pi log sine x. So I is pi by 2, 0 to pi log sine x dx. Now what we can do is we apply the another property, which is from 0 or okay, let's write first. Say if 0 to 2a fx dx equal to 2 times of 0 to a fx dx, if a is the period of this function. So if we apply this, and this property has come from this, that Queen's rule, that is 0 to 2a fx dx equal to 0 to a fx dx plus again 0 to a f of 2a minus x dx. Okay, so we can write this is pi by 2, 0, and this, if we put sine of pi minus x, that is sine x, which means this will this upper limit can be write as this. So this is ln of sine x. Okay, and now this 2 will come down, so 2 and 2 will get cancelled. So this is 0 to pi by 2 ln of sine x dx. So this is I. Now we apply the King's rule. So this is 0 to pi by 2 ln sine of pi by 2 minus x means cos. So this is cos x dx. So what we can do is we add this to, so this is 2i pi 0 to pi by 2 ln of sine x plus cos x. Okay, so apply the property of log. So this is ln of sine x into cos x. So we can write this is 0 to pi by 2. This is ln. We just multiply and divide by 2. So this is sine 2x minus ln 2. Okay, we have right directly. So this is 2i basically. Okay, so now 2i is pi 0 to pi by 2 ln sine 2x minus pi 0 to pi by 2 ln 2 dx. Now this integral, which is this sine 2x. Okay, so we just substitute 2x as z. Okay, so if we substitute 2x as z, so this integral will become, this is 0, and if we put the upper limit pi by 2, so this is pi and ln sine z and dz by 2 dx equal to dz by 2. Okay, so this will become half of 0 to pi ln of sine z dz, which is same as I. You see, this is so we can write 2I equal to, so this is pi by 2 0 to pi ln sine z dz, or we can write as sine x dx. So, and this integral is pi ln 2 and this is pi by 2. Okay, so this is pi by 2, and again this if we put x as here, so this can be written as 0 2 into pi by 2. So this is ln sin x dx. So pi square by 2 ln 2. So this 2 will come down. So you can write this as pi 0 to pi by 2 ln sin x dx. This is pi square by 2 ln 2. And now this term pi 0 to pi by 2 ln sin x, this is I. See here. So this is I, y minus pi square by 2 ln 2. So we have I equal to, taking I to that side, minus pi square by 2 ln 2. So this is our final answer. So similar type of problem can be written as, say, let's write ln 0 to pi by 2 tan x plus 10x plus cot x. Okay, so what we can do is we just first put sine and cos. So this is sine square x plus cos square x divided by sine x cos x. Okay, so 0 to pi by 2, this is ln 1 by 2 sine x. So we multiply it by 2 and this is sine 2x. Okay, so this is 0 to pi by 2 log 2 minus 0 to pi by 2 log sine 2x dx, and this is originally I. Okay. Now what we have here is we have to, okay, this first part is simple. This is pi by 2 ln 2 minus, and this is, say, let's say this is I1. Okay, so I1 is ln sine 2x dx 0 to pi by 2. So put 2x as z. Okay, so if we put 2x as z, so we can write this as 2 dx equal to dz. Okay, so this is 0 and 2 pi ln, this is sine z and dz by 2. Okay, now half 0 to pi ln, again this is a periodic function from 0 to 2 pi, because if we put pi minus z, so this is sine z, so this is sine z dz. So dz. Okay, Now this 2 will come down. So this is half will get cancelled. So this is 0 to pi by 2 ln sin z dz. So this is again I1, which means what we can do is we put this is I1. Okay, so I1 is 0 to pi by 2 ln. We apply the King's rule. So this is cos sin pi by 2 minus z. So this is cos z. Okay, so now again this we add. So which means 2I1 is 0 to pi by 2 log sin x plus cos x, which means sin x cos x dx. So which means 2I1 is 0 to pi by 2, and again we multiply and divide by 2 and 2. This is sin 2x minus ln sin 2 dx and dx. Okay. So this is ln sin 2x dx minus this is pi by 2 ln 2, and this is 2I1. Okay, so now this portion I1 is 0 to pi by 2 sin 2x dx, so which is same as this part. Okay, so this is actually I1. So this is 2I1, this is I1 minus pi by 2 ln 2. So which means I1 is minus pi by 2 ln 2. So now substitute this I1 here. So which means our original equation is pi by 2 ln 2 and minus I1 is minus 1 plus pi by 2 ln 2, which means I is pi ln 2. So this is our final answer. Okay, so here you just remember two direct formula, which is 0 to pi ln sin 2x dx, which is equal to 0 to pi by 2 ln sin x dx and 0 to pi by 2 ln cos x dx. All have the same integral value, and which is minus pi by 2 ln 2. Just remember this. Okay, this is pi by 2. This is pi by 2. So this has a same answer. This is all for the day. See you in the next video.